All right, so now that we're going to work with volumes, I like to go into the viewport sometimes, meaning move your mouse over it, press D to bring up the display options, go to background, which I already had it set to, and go to dark. So, navigate to background if you're not there, go to dark. You don't have to. I just like to, I think it's easier to see volumes, especially faint volumes, over a black background. So there you go. So now that these points have a density attribute, and they're all set to 1, we can do a rasterize attributes, or rather volume rasterize attributes. So the attribute we're going to rasterize is the density attribute, the one that we just made. And there you go. So now we can see a sphere based on where those particles are. Now, if there is the p-scale attribute, p-cake. P-scale, by default, if there is no p-scale attribute, which there wasn't, it would be assumed to be 1. So if I just put 1 here, you'll notice nothing changed. If I put 0.5 here, it's half the size, or at least it's half the radius. Again, if you have nothing, it's just 1. And if I go down here, I can modify it further. I can also change it here. We are going to modify the p-scale, though, such that it is big at the beginning and small at the end. So let's do that. If I were to say the p-scale is the age, which is an attribute that comes out of the particle sim, divided by the life, which is the total length of the life, we're going to get how far along we are from 0 to 1 of its journey through life. So there you go. You can see they're getting bigger until they get fully size 1 and they blink out. A little fun fact is you can do, there's another built-in, or these actually aren't built in. These are actual attributes. There it is, age and life. There's another thing called nAge, just for fun, just so you know, which is a built-in that does that single division for you. It's an implied attribute. It's not actually listed here, so you get it. We're just going to use that. nAge is what it's saying. And of course, we realize, though, we don't want it to get bigger as it goes. We want it to start big and taper out. So this 0 to 1 needs to be remapped to something else. Let's use a ramp. So channel ramp, call it something, ramp size. The input is a 0 to 1, which is this, and the output will be a new 0 to 1 based off of the ramp that we draw. So click on this. If you aren't familiar, it will create the ramp. It will find that this ramp size, this ramp, named ramp size, doesn't exist, so create it. So that's cool. Now by default, we have this ramp, which is saying the inputs are along the bottom, the outputs are along the side. So an input of 0 will yield an output of 0. An input of 1 will yield an output of 1, which is why it still looks the same. So if we wanted to reverse that, say an input of 0 yields, come on, I'm trying to grab the point itself. There we go. An input of 0 now yields an output of 1, and an input of 1 now yields an output of 0. So that's much closer to what we want. You can see it starts big and gets smaller. Now if we wanted to do that, we could have just said 1 minus nAge. So we might as well take advantage of this. I'm going to say for the first half of your life, you are your full size. Then on the way out, you have this kind of cool looking ramp down thing. If you want to get fancy, you can do, you can round these things out by changing what they are like that, or, you get it. It doesn't really matter. You're not going to notice it either way, so I'm going to keep them as linear. But something like that. And there you go. So you can see they say whole, and then they fade out. So that's cool. What else can we do on this, though? For one, the smaller the voxel size, the higher res it is. I mean, it's still a sphere, so it's just a more high res sphere. But we will tie this to our actual simulation voxel size later. Coverage scale is how dense it is. So if I put 10, it's now a density of 10 essentially. We can't really see that. It doesn't look like it's a dense thing because we usually associate a shadow with a very dense volume. So what we can do is kind of rotate maybe 45 degrees to the left, maybe 45 degrees up, more or less. Control click on distant light. Don't worry about what you see through this. Just go right back into our camera. And now you can see there's shadowing on it. So having a light in the viewport, and if you make sure that you're on the nice light settings here. This is the one above the texture one, high quality lighting with shadows. We can see nice little shadows on it, which is, it's nice. Nice to see shadows. We can make sure that we don't render that light later, but it's nice to have it for the viewport. Okay. We can also, as this moves through space, these are going to be the sources to our pyrosim. So we don't want to have it jump from here to here to here, especially when it's going fast coming out at the beginning. We don't want that kind of strobe effect be in our source. We want to blur this. So you can see now it looks like more of a streak. Like so. Just a little thing so that on any given frame, it's connecting on the next frame, it's kind of continuing a continuous line of sourcing. In fact, we need to increase the shutter for that streak to fully take place. Now you can see it easier. See how this streak from the last frame, the particle is here, and on this frame it's here. So it's streaking it through here. You can give it more samples. No real harm in that. It just slows down this process, but if it's still lightning fast anyway, it doesn't really matter. But just to drive that point home, so the particle went from here to here, and now watch on the next frame, the streak continues from here to here, and from here to here, and from here to here. So we get an unbroken sourcing into our sim. So that's cool. One little caveat is we've got the particles are here, but look where the trail is. It's starting here and going up. That's because the shutter offset is a +1. Change this to -1, and you can see it now is trailing. It's saying go to the -1th frame instead of the 1th frame. So all that is to say, it is now a trail of smoke coming from behind the particle. Awesome. So that is the general source, but let's add some noise to it now. Lots of ways you can noise up sourcing, but because in previous lessons we've started with a lot of particles, where a particle basically represented a voxel, we were noising up the attributes on the particles. In this case, this whole volume area is represented by a single particle. So we can't noise this attribute because it would represent the entire sphere's value. Now that we have a volume with many voxels, let's just take our noise directly to the volume. Let me just show you what I mean. Volume VOP. So VOPs are just node-based representations of vex code. I like to use VOPs for noise because when I drop a noise down, like anti-alias noise, I have all my parameters here all set up for me already, and I don't need to waste my time on a wrangler setting them up. So what do we have in here? We have an input density value, and we have an output density value. So density, famously, is the actual how much stuff is in a given voxel. So we want to multiply the density by some noisy thing to kind of break it up. The noise exists in space based off of the position, the X, Y, Z position, and also time, if we wanted to. And we do. If we don't base off of time, the noise will just be fixed in space, and any sphere that passes through the noise will be broken up the same way. So we might as well have it just be more robust. So find the vector to vector form. This is how we will package up space and time, the 4th dimension. So this output is a 4-dimensional thing, X, Y, Z, and time. That will be the input to our noise. So 4D input, 1D noise output. And then we also really need to do is multiply the density by that. And there you go. So now it's broken up. So that's looking nice already. What we might want to do is fiddle with the noise itself. So I'm going to say like increase the frequency so that the actual patterns are smaller. We could also increase the roughness so that we get more granular detail in there. This will become especially important when this voxel size is smaller later. See? Because there's going to be more detail in the voxels to capture all of that. So this is a nice looking, interesting input. I'm going to go back. Actually, I'll just keep it at 0.04 for now. Again, we'll tie that to the sim later. The last thing I might want to do is fit range. We can just remap any potential negative numbers that are coming out of this, depending on the noise, the kind of noise you're using. Anything below 0 will just be mapped to 0. Or maybe 0.1. Maybe we always want a little bit of smoke no matter what in these areas. So if I disable the multiply, you'll see what we originally had. You'll see what we have now. This will be your, artistic idea later, is how you will, mess with the noise or how you would affect the inputs or the sources here. But suffice to say, the more interesting your input into your sim, the more interesting your sim will be. So it's nice to break up the noise like that. I would say for fun, try doing this, follow along with what we're going to do, which is this being 0.1. Try doing it later with it being 0. You'll get a lot less smoke in, but it'll be a lot more, chunky and staggered. Maybe that is something that you want. So again, you have a lot of artistic control here. So there you go. That's it for the noise. And so I'm just going to make a null for fun here. I know we're going to have more sources later, which is why I have this kind of like waiting over here so I can put more in. We'll just call this source, and that's it.